So the maximum and minimum come under something called order statistics. So if you have in general many random variables x1, x2, etc., xn, you can think of the best case analysis and the worst case analysis. So every time you get a set of observations, you order them. So let's say I teach this class 10 times. Every time I get 30 students. So I can take the best score and plot it, right, over all classes, and the worst score. So that will tell you something about the student performance over various realizations. So each one. So to start with, the simplest case you can think of is with the two random variables, maximum and minimum. So they are nonlinear functions because they are not addition or sum. Ratio, that's also ratio, which we consider also nonlinear function. Amplitude is nonlinear function. So the question is, what is the density function of z here? What's the density function of w here? So again, if you look at the maximum and minimum, even though they are nonlinear functions, you can see there is a natural partition, because if x is greater than y, what happens to the maximum? So if x is greater than or equal to y, the z is x, and if x is less than y, z is y. Same thing here. If x is greater than or equal to x, minimum is y, the other way, right? And if x is less than y, x is the minimum. So suddenly this has become linear. But you could, once you get used to this, you could try to do this problem. So then it will be x squared, etc. So you see, you can make up your own problems, but let's stick with the classic stuff. So the distribution function of z, again, we would start as probability of z less than or equal to z. But as I said, we need this partition, so I'm going to call this A, then this will be A complement. A union A complement is the whole set. They are mutually exclusive. So I'm going to here intersection with A union A complement, no change. So this is the same as z less than or equal to z A plus probability of z less than or equal to z A complement. So A is what? When x is greater than equal to y, from here, c less than z. C is the same as x less than z. Because I'm just copying from here. Z is x less than c. Plus, when x is less than y, y is greater. So y less than z. So it is this too. So where is the region? That's easy to draw. So we want the x equal to y. So in one case, x greater than y, right? So that would be this. This would be the region x greater than y. And then we want x less than or equal to c. So this is the line x equal to z, right? X less than or equal to c is where? To the left, right? So it would be up to here, right? So that will be one region. In the other case, x less than y, which would be all of this. That's x less than y. And y less than z. So this is the point z comma z. So this is the line y equal to z. So y less than c would be this region. So where both this, y less than c is of course this region. So you have to put this together with this. So the whole thing is going to look like this, isn't it? So this of course looks like, now if you, from the diagram it looks like that's the same as x less than c and y less than c, isn't it? Look at there. If once you put the diagrams together, take this point is also c comma z. So take this and put it here, it will be this region. So this plus this, I just wrote it here. But if you look at here, this here x is less than c, y is less than c. But that is by definition fcz, right? fxy z comma z. So what I am trying to say is fcz turns out to be fxy z comma z. So it's the density function is what it is. You have to take the derivative with respect to z. Of course, if x and y are independent, this becomes a product and you can proceed and so on. Let's do the minimum. Any questions here? Look here. Now, at this stage you may say this makes sense because FCC what? Probability of maximum of x comma y less than or equal to z. You could also argue that, look here, if maximum is less than something, x has to be, each of them has to be less than that. X is less than c. So even if you had maximum of x1 comma x2 comma xn greater than z, I'm sorry, less than or equal to c, then you could say x1 has to be less than or equal to c, x2 has to be less than or equal to c, and so on. The generalization is equally easy. So let's do this one. The same partition works here. If this is A complement, A union A complement is whole set, A intersection A complement is empty. Same thing here. So the distribution function of W, but W is going to be minimum of x comma y less than or equal to W. So we bring in the partition. Let me call this to be B. So B intersection A union A bar. A is, so this is BA plus BA bar. So what is B? A bar, A is what? A is x greater than y plus probability of x less than y. Now look here, when x is, we have it here, right? When x is greater than y, minimum is the smaller one. So I have it y. So this will be y less than or equal to lowercase w. When x is less than y, minimum will be x less than or equal to w. So next is figuring out this region and putting it together. So this is the line x equal to y, right? You need the line x equal to y. This is the line, that's not the line. This will be the line x equal to y, right? Okay, let's see. So as before, this is the region x greater than y. This is the region x less than y. Then you take the point z comma w comma w in this plane. This is x, this is y, this is of course x, this is y. So now we want the, previously there it was x less than w, here it is y less than w. Y less than w is this way, isn't it? Below that. So it will be this region. Below this. This is the line y equal to w, so it's below that. And here we want the line x equal to w, which will be this way, right? So you bring this point, this one. This will be x equal to w to the left of this, and so common will be this region. So this point is this point. So you see this wedge, and then you have this wedge, right? So this wedge will come and sit here. So don't you see this? It will be all this, right? This is one wedge, this is the other wedge. This wedge will come and sit here. So I put, and this is the line, right? So this is easy to figure out. So the where is it? Somewhere here, right? So FWW would be, so you need to sum up all this. So this is going to be probability of x less than or equal to, remember this point is W comma W. So this is probability of x less than W, y less than W. But this region we counted twice. So we will subtract it out. Right? So isn't this same as fx of W, because probability of x less than W, from there probability of y less than W. But in this process, x less than W is this, y less than, so we took care of this, but we took care of this twice now. So we will subtract one once, the probability of x less than W and y less than W. Oh, so this will be fx of W plus fy of W minus no, if x and y are independent, so this is always true. If x and y are independent, this becomes FWW becomes, look at here, fx of W plus fy of W. This becomes the product. So this becomes fx of multiplied by fy of W. So from here the derivative of derivative will give us the density function. What is the derivative of this with respect to W? Anyone? What is the derivative of the distribution function of x? If it was x here, what will you get? fxx. So if it is W here? This is only this variable. Hello, what was it? It will be fx of? And here you use the chain rule. So this will be fx of W minus, fy of W minus fx of W. So if you want, you can write this as right. So finally, let's say I'm here. Also say they are exponential with parameter lambda. So what is the problem? X and y are independent exponential random variables with lambda. So all I have to do is substitute the exponential, right? What is the exponential density function? This is lambda e raised to minus lambda, right? That's easy. We'll come here in a second. This is lambda e raised to minus lambda W. Anybody remembers what is the distribution function of an exponential random variable? Of course you don't remember, so we'll do it. Distribution function of a exponential random variable is 0 to W lambda e raised to minus lambda x dx, right? So lambda e raised to minus lambda x minus lambda cancels 0 to W. So what do you get? Because of the minus 1 minus e raised to minus lambda W. So 1 minus of that would be? All right, e raised to, same thing here, right? So this will exactly the same. So you get, this will get 2 times. In fact, let me change it. I make it lambda 1 and lambda 2. X and y are, So this will be lambda 1. Look at here. This will be lambda 2. This will be lambda 2. This will be lambda 2. This will be lambda 1. So if you do it, don't you see what do you get? Right? What is this form? Anybody? No, what is the form? Back to exponential. So again, another interesting result. This comes in queuing theory all the time. If x and y are exponential, independent exponential with parameters lambda 1 and lambda 2, the minimum of x comma y is also exponential. Maximum is not exponential, it's some mess, but minimum is exponential. So let's do that problem quickly. So that's a discrete random variable. So you can repeat all this now, discrete random variables also, right? So x, this is the problem. X is geometric. Geometric means and y is also geometric. Or z is x plus y. So look here, z is given to be x plus y, so z equal to, so this much is easy, right? So few things are clear. Look, x takes the value 0, 1, 2, 3, etc. up to infinity. Y takes the value 0, 1, 2, 3, etc. up to infinity. So if you add x plus y, it takes what kind of values? 0, 1, 2, 3, etc. So we need to find this for k equal to 0, 1, 2, etc. up to infinity. That's the problem. So this would be a probability of z equal to k. And look at here. Here you can, if k is going to be some number like 10, then what are the possibilities on x and y? In a sense, this is simpler. X could be what? The sum has to be 10. So x and y can be? So from where to where? Only 0 to 10, because x cannot be 11, because then we cannot maintain this, right? So if x is I, what is y? And what any condition on I? So you are saying this is the same as probability of x equal to I and y equal to? But how about k is what it is. K is given to us because z is k. K is given. So look, z equal to k can be written as, this event can be written as x equal to I and y equal to k minus I. That's true, right? Right? This is one event. But how many such events? I could take what value?
0 to less than equal to k.
So let me call this to be ai. So in that case, don't you see that z equal to k is this event is the same as, I could take what value?
0 to 0.
I could be 0 or union, right? A1 or etc. or A10. Isn't this true? AK, right? Because it could be any one of these possibilities, right? These are the only possibilities, nothing more, nothing less. When z is given to be k, x could be 0, y could be k. X could be 1, y could be k minus 1, etc. So that's what this is. And all these are mutually exclusive, isn't it? So the probability of this is the sum of the probabilities. So can't I write here, this is the same as, this is what I was going to write. Isn't that true? I just wrote what I said. Probability of this is probability on this side. which is probability of AI summation I goes from 0 through k, this one, right? What is the advantage here? Look here. And I don't know whether I wrote it here. Let's also give and say x and y are independent. So if x and y are independent, then look at here, the top expression, this becomes the product, right? So this is summation I equal to 0 through k. This is probability of x equal to I, or probability of y equal to k minus I. So this is summation I equal to 0 through k, p q to the power. Look at there. X equal to I. This is p q to the power. So you see qi cancels. So what is the answer? Anyone? That's the answer. What is the answer then? Of what? So what do you get? Also wrong. What do you get? How many terms are here? This is very important. Here you can't get sloppy. You lose one, you lose whole points, right? You lose a 0, right? Now I'm going to leave it to you to go home and how do you know this is a density function, whether we did this correctly? What is the summation. No integration, summation. So you'll go home and see whether probability of z equal to k goes from, hello, k goes from, not 1 to infinity, you write 1, right, 0 to infinity. You need to check and see that everything works out to be 1 or not. So let's do one more problem and that should be good. So that's a, so you see you're not going to do this one day before the exam. So you need to practice this out and get very comfortable. There will be problems of this type in the midterm, right? So let's say z is maximum of x comma y. So probability of w equal to k, it's very clear. W take, if the x and y are discrete, w is discrete, right? What is the range on w? K goes, x and y goes from 0, 1, 2, 3 up to infinity. And w, its maximum. So suppose x is 0, y is 0. Then what is the maximum of x comma y? All right, so what is the range on w? No question, the range is 0 through infinity, right? That's all I can say. I'm not trying to trick you or anything, but this needs to be clear, right? If you write this, that's wrong. Hello? That's wrong if you write only 1 through infinity. Even if it is minimum by the same argument, range is 0 through infinity. So this is given to be maximum of x comma y equal to k. Of course, here the problem starts because it's a nonlinear function. So we'll try to use that idea and see here it works. So this is the same as probability of maximum x comma y equal to k and x greater than y plus probability of maximum x comma y equal to k x less than y. Is this true? Why? You just go through this argument that we just went over here, right? When maximum is there, remember this is the way you intersect here with the whole set, which is A union A complement. A and A complement are mutually exclusive. So you can write this as the sum of two terms, maximum of, so here just to say one line, when x is greater than or equal to y, maximum will be what? X. And when x is less than y, maximum will be y. So probability of w equal to k is the same as probability of x equal to k, x greater than equal to y, plus probability of y equal to k, x. Now don't be sloppy and do like this, because equal sign is already taken care. If you write like this, you are repeating stuff. So you have to be you should only write what you mean. Right? So look here. This is x equal to k. Look here, x equal to k. So I can replace this x by x is k. K here, right? So this is, isn't it? I just put k here. That means y, what is it? Right. Plus y equal to k, and y is k, x less than k, right? All right, next what? Look at here, x and y are separate, so they are independent, right? The same problem. So this is the same as probability of x equal to k multiplied probability of y less than or equal to k plus probability of x less than k probability of y equal to k, right? Because of their independence. Any questions? So now we can simply substitute. So this is going to be p q to the power, you already know the answer, p q to the power k. Look at here. What does this mean? Y less than or equal to k means? No, y is less than or equal to 10. That means what? So look at this. Y less than or equal to k is the same as y equal to, y could be what? Y could be 0 or y could be 1, etc. Y could be k. So look at here. These are all mutually exclusive. So the probability of this is the probability on the right side, which is the sum of the probabilities of y equal to I. I goes from 0 to k. So this is the same as summation probability of y equal to I. I goes from 0 through k. And look at here. Here, this is the same as probability of x equal to I. I goes from
0 to k minus 1.
very important here. You put it k, you're done. In the wrong way, right? So probability of y equal to k is p q to the power k. So let me substitute here. So this is p q to the power k multiplied by p q to the power I. I goes from 0 through k plus p q to the power k summation p q to the power I goes from 0 through k minus 1. So p squared is common. Yeah, q to the power k seems to be common. Then you have, so anybody knows what is the sum of, it's getting late, q to the power I equal to 0 through k? All right, this is 1 plus q plus etc. up to q to the power k. This is k minus 1. 1 minus q. 1 minus q is? p, and I'm going to cancel one p here. So this is 1 minus q to the power k plus 1 over p plus this will be what? Same argument. 1 minus
Q power K.
over
1 minus
1 minus q, which will be p. This p cancels here. So the answer turns out to be pq to the power k multiplied by, look at here, 2 minus qk minus qk plus 1. K goes from 0, 1, 2, etc. infinity. Again, the same question I would ask, how do you know this is true? So you have to go home and sum this over, which we can do here quickly, and see that it turns out to be 1. So you do the minimum etc. at home. So probability of z equal to k. K goes from 0 to infinity. This is a check. So this is 3 terms, right? So first term is 2p summation qk. K goes from 0 through infinity, right? 2qk minus what? P is common, so I'm going to pull p outside. P is common, then you have 2k. Here you have k goes from, is it? Q, right? So even exam, you should do all this, make sure it checks out. Even I don't know whether the answer is correct, we'll see. So anybody? What is the answer to this? 1 over 1 minus q, which is 1 over p, right? Right? Plus, what is the answer to the other one? So q squared is the term, 1 over 1 minus q squared, right? Minus, right? Minus q, 1 over 1 minus q squared, right? 1 minus q squared is p multiplied by 1 plus q. This is p multiplied by 1 plus q. So p cancels. So I get 2 minus 1 over 1 plus q minus q over 1 plus q. Let's see whether it works out or not. Otherwise, you check and find out the error. What happened? Okay, so everything is good, right? All right, so this is the nature of the problem, right? So if you do this right, then otherwise you have a vague idea, okay, whereas here you can clearly do this. X and Y are independent Gaussian equal variance. Amplitude is Rayleigh because you can do it and show. All right, so I'm going to stop here.